In this part of video, we are going to discuss briefly about what are the operators available in Python and what are the things that we can perform by using those operators on numbers or strings or any other data that we have fed up with. So let's go on. So what are the operators that was available in Python? So this is the next question. To answer the question, you can list out the operators which are legal in Python. They are arithmetic operators, assignment or operators, comparison operators, logical operators, identity operators, membership operators, and bitwise operators. And we will brief in few minutes what are they and what are they able to do. So what are all the arithmetic operators present in Python? So it starts with addition, subtraction, multiplication, division, modulus, exponentiation, and floor division. And you can see in the slides the what are the operators that can be used to perform the operations, and you can see the example in the rightmost corner as well. And in a moment we will see what is how the arithmetic operators will actually be performing on the numbers and what are the output could be. And here we go with the example of arithmetic operators, and here we are going to read two numbers and we're gonna read it as a string objects because by using input function everything has been read as string objects that we have just now seen, and we need to convert that into its respective integers by using a function integer int, and then the value has been assigned to x and y. So those two lines, first line and second line, you can see that, and the rest of the 7 lines we are about to print. So those were display functions, and we are going to display two things. One is a string and a value. Those which are enclosed inside a double quotation is a string that you know, and here I use some sub product, division, modulus, exponentiation, floor division for the better understandability of the result. You should know how the value comes, right? So for that I use that, and which is separated by comma. Whenever you are supposed to print so many things, you have to separate it every single type of data type by using comma. Here I'm going with x plus y as an addition expression which takes the value from x and y, it adds and it goes on. The point here is we need to look at the line 6 and 9. So one is division and the next is floor division. You can straight away look at the output. You can find out what is the difference among a division and a floor division. Of course both are dividing. You take with the example 3 and 2. If you divide 3 by 2, you will get 1.5. so if you are using an ordinary division x divided by y, you will get 1.5 as a float result. Where in case I don't want to have the float result, sir, I want to have the the only whole numbers. So in that case, I need to go with floor division. In floor division, you should be remembering that it doesn't round off to the highest value. It always round off to the floor value, which is the lowest value. In this case it is 1.5. You can see the output of division, it is 1.5. Even though it is 1.999, it is still round off to 1. So that is where you should be very careful while using floor division. The next question in Python would be, what are the comparison operators are available in Python? Or they can ask like, how can you compare two different values or two different results? So you should not always think that x and y as a single value. It can be a result of an expression also, or it can be a condition also, who knows. So whenever we are about to use to compare two values, so these are the ways you can compare it. Actually you can compare whether both the values are equal by using two equal to operators, and which is followed by not equal, x is greater than y, or x is less than y, x is greater than or equal to, and x is less than or equal to. And here you should be careful that all the comparisons were made with respect to the first value. With respect to x, we are checking the next argument y, next value y. Okay, so that should be noted. And here goes the example for comparison operators. The same, we read x and y and we're going to check whether x and y is equal to or which is not equal to, greater than, less than. You has to note that for all the comparisons we made, we can either have true or false, only boolean return values. Okay, so it will, if the condition is true, if x and y is true, sorry, x and y is equal, then the third statement, print x equal to y, returns true. In this case, x is 10 and y is 20, which is not equal, so it will be displayed as false. Then you go with the fourth statement, x is not equal to y, which is actually true. They are not equal, they are different numbers, so in the fourth line of the output it will be displayed as true, and it goes on. You just check with the different values, you could be able to map the output and the input. So the next important questions you might expected in the interview with respect to Python operators is logical operator. The logical operator used to combine two conditional statements. So you have to be very clear and concise that before we have discussed about, we are comparing those, also we are comparing two values or two values of an expression. Here we are comparing a logic, so the same thing, but whenever we are going to combine more than one conditions on a same statements, we are going to use this logical operator. So there are three types of logical operators: and, or, not. And will returns true always if and if only both the statements are true, and which is not the case with or is very liberal. In fact, if any of the statement is true, if any of one part of the logic is true, if it returns one, it will returns one. It will return false only when both the sides, a and b, both the sides are false, both the logics are false. And not is simply a complementary. Whatever you give, it just flips. If we speak about, if you give about true, and it will flips into false, and if you give a false value, it will flips into a true. And here is an example of logical operators. We have four lines, we got a number x, and we're gonna check with different logics. Okay, in second line we are going to check and operator, how it works. And let us consider the value of x is 8 as in the output screen, and you just go with those conditions. 8 is greater than 5, which is true, and 8 is also less than 10, so that also true. So since both the parts are true, it will return true, and you can see in the second line of the output it is true. And you go with the same value x equal to 8 with to the third statement, and there we use or, logical or, and there 8 is less than 5, which is false, and 8 is less than 4, which is also false. So since both the logics were false, we has to return false. So the third line of the output, you can find it as false. Similar to that, in the last line we are going to check the not operator. We are going to check whether x is greater than 10. 8 is not greater than 10, which is actually a false. So not of false, so we're gonna flip that. False has been flipped into true, so in the last line of the output you will get true. Python identity operators. Actually, this is one of the important question, and it is very tricky. In fact, to understand the question, you should have some deeper knowledge how the Python is allocating memory and to its variables. Okay, let's go with the slide itself first. So what is Python identity operators? See, identity operators are used to compare two objects, since all the inputs are objects. Okay, so we are going to, at the end of the day, we are going to compare two objects, not with they are equal. We are not going to compare whether these you are having two values at your hand, two objects at your hand, whether these two values are equal or not. For that we are not going for identity operators. Rather, we are going to check whether you are referring to the same object with same memory location or not. Okay, so where it arises out of. So now with this example, you just go and experiment yourself that you give a equal to 5 and again b equal to 5, the same value. Now you go and check what is the memory location of a and b by using the function called id in Python. So you will be surprised to know that both a and b will be referred to the same memory location. Unlike C or Java, every variable that has a different memory location, that is not the case here. Here all the identifiers are references to a memory location that holds to a value. So okay, when we will be having a independent memory location, sir? Yes, when you are going to change the value from 5 to 6 or 5 to 4 or to some other value of either A or B. Let's say an example, I'm going to change the value of B, right? So in case if I'm going to change the values B equal to B plus 1 in the next line, now Python is going to allocate a different memory location for B to hold 6. Now these two A and B will refers to a different memory location. Until unless you can give 100 different variable names to a same value, it will refer to the same memory location. So identity operator is going to check whether it refers to a same memory location or different memory location. Is or is not. Is an operator that returns true if both are same object. Okay, x and y are same. You are referring to the same object by using different names. Okay, so is not is an operator that returns true when they are not the same operator, because we might arrive to the same value by doing two different operations also. 4 minus 3 is equal to 1, 2 minus 1 is also equal to 1. Here these are two different operations that arrives to the same value. Because of being the same value, you cannot say they are the same object. So you understand the point, right? So that is the difference between is and is not. Okay, let us understand the operators with an example here. As usual, we are going to read two values x and y, which is x equal to 10 and y equal to 20 in this case also, and we are going to assign x to a new variable z. So z equal to x. Okay, then we are going to check all those uh, operators to check, I mean identity operators, whether how it works and all. Okay, let's go with the fourth line straight away. Print x is y. We are going to check whether x and y refers to a same memory location. For that, the value needs to be same, right? Here the value is itself different, so definitely it returns false. So it returns. And then 6, x is not y. Yes, it is not y because it is different. So it returns true. And the tricky part came the last line, x is z. So here the last slide only I have explained you what is happening in the backyard of Python while assigning a value or variable, how the naming is happening there, and what the references is all about and everything. Okay, so here in third line you are assigning z equal to x. So here take x equal to 10, so it is equivalent to z equal to 10. But since x and z has the same value 10, z will not be given, z or x both will not be given a different memory location, both were referred to the same memory location. So in this case, if you check x is z, yes, as of now both are the reference to a same value, that must be true, and you can see in the last line of the output screen it is true. Next important question in terms of operators is membership operator. So membership operators are used to test if a sequence or a particular pattern is present in a sequence or not. So you can check one number in a sequence or a particular pattern in a string also. In both cases it will work, and it also checks out particular number is present in a range of numbers also. So There are two types of operator, in and not in. And in returns true if a sequence with a specified value is present in the object, which means that we found out what we actually searching for, if it is actually present. For example, a set of n numbers. In that n numbers, I'm going to find a number whether it is present or not. In case if it is present in the number in the set, then it returns true. Okay, and not in vice versa. So if it is not present in true, I'm searching for an element which is not present in the set, then it returns true. Okay, so we will go with the example. Yeah. So here is the example, and it starts with x equal to inside a square bracket 1 2 3 4 5, which is called as a list. A list is a data structure which is present in Python, and it is an ordered and mutable sequence. Ordered in the case every element in the list has been indexed. So what index refers to? Index is simply a name of every data element which is present in a sequence. So like x is a common name, refers to the group of the elements, right? Group of the data. But if you wanted to fetch any one of the data which is present inside a list, so you need to call it, right? You need to call the particular element, right? So to call every element individually, we are using the index. So index is system generated and it starts with 0. So here there were 5 elements, so the index starts from 0, so it goes on till 0 1 2 3 and 4. So what is the index of 5? Here it is 4. Since it starts from 0, it ends with n minus 1, where n is the size of the elements, or size of the list. Okay, so going from left to right, it starts from 0 to 1, and from right to left it starts from negative index. We call them as a negative index, minus 1 to minus n. So what is the negative index of 5? Which is minus 1. And from minus 1 it goes on increasing, minus 2 minus 3 minus 4 and minus 5. So 1 represents, there were two indexes for 1. If you access it from left to right, you can call it 0, and if you wanted to access it from right to left, you call it as minus 5. So both refers to the same element. So this is called indexing in list or in any ordered sequence. Then we go to the next line. Y, here we are prompting the user to give an integer value, and which is stored in y. And now there are two other print statements. In first print statement, I'm going to check whether y is present in x or not. If it is present in x, it has to return true. And second print statement, we are going to check whether the y is not present in true in the list. If y is not present in true, it must in the particular list x, it should return true. Okay, so let's have the value y is 6. So by looking at itself, you can know that it is not present in the list. So the first print statement, it checks whether y is present in x. No, it is not present, so it returns false. And the next print statement, it checks y should not be present in x. Yes, it is not present in x, so it returns true. So that is how true and false are mapped in the output screen. So the next thing we are going to discuss about is bitwise operator, which is very important operator, because you are going to perform the operations in bit level, which is binary equivalence. So whenever we are doing some operations in binary level, which means that we are doing something which is very close to machine. So great care should be taken whenever you are doing any kind of operations in binaries. Okay, so the name itself, bitwise operator means, so all the operations is going to be performed on bits. So you have to convert the number into binary straight away. So instead of converting it, if you go and look, for example, 4 and 5, how it becomes 7, you don't know. In no way you can map it. So you can only mapping it by converting that into its binary equivalent and perform the operations on the binary numbers. Then you will get a result, right, in binary. Then convert back the binary into the numbers. Then you will find the output. So this is one of a tip to understand the bitwise operators. And here in Python we have 6 bitwise operators: and, or, XOR, not, left shift and right shift. So we'll see in brief what are they with an example. Here we go with an example 53 and 38. first step is that you just convert that into its binary equivalent and then write. Then after that we have to perform AND operation with the both the digits. For you take the last digit of both the numbers and perform AND operation on those digits, and you will write the result in the next line as in the example, and you perform that with the leftmost digit. And you can fill, if the second digit is smaller than the first digit, you can fill with zeros if there is any vacants. And yes, you will get a resultant binary and then convert the resultant binary into its equivalent number. Then you will get the bitwise and value for those 53 and 38. And the same thing is followed for OR. The only one condition over here is if any of the input is 1, then it will result in 1. So that is OR. So by using this rule, you just try to compute all those OR values for every digits in both the numbers. You take both numbers in the same digit wise positions, and then you compute OR and write the resultant. And after completing all the digits, you just convert the particular resultant into its equivalent number, and you will get the bitwise XOR value of 53 and 38. And similar to that, you go with bitwise XOR. You just look at the example. If both the inputs are same, 1 1 or 0 0, it results in 0. If any change happens, if one input is 1 and other input is 0, or if one input is 0 and other input is 1, and it results in 1, that's all. That is the difference. Then you can go on with that, and as we did for and OR, you left from the rightmost to the leftmost digit, you complete it and then get a resultant value and then convert it to the number, and you will get bitwise XOR. And not, that it is very easy to work on. Not, it just flips 1 to 0 and 0 to 1. It starts from the leftmost value. Okay, it starts from the leftmost value and rightmost value, and it tries to go to leftmost, and it will flips all the digits to other digits until its first 0. Okay, if it reaches first 0, and it will stop it. That you should remember that. And left shift is that the first number is 25, that is 25 shift 2 times there. So how many times you wanted to shift, you just add the number zeros to the leftmost thing, and then you just simply push the number to the 2 bits left, which means that you add 2 bits 20 to the rightmost, and then you complete it. You convert the number into its binary equivalent, and you will get the left shift value, bitwise value for the particular number. How many times you wanted to shift, that many zeros you should add to the rightmost, and you just convert. Then after inserting the value, you just convert the particular resultant binary into its equivalent number. Then you will get the shifted value. The same thing will be followed for right shift. In case of right shift, we will be dropping the digits. Okay, so for the example, the same example 25, if I do the right shift 2 times, then I should drop the rightmost 2 digit. Then I will be having only 1 1 and 0. Then I need to convert this 1 1 0 into its equivalent, and we will get the value. So that is all about bitwise operations in Python. So it is one of the most useful operator which is present in Python. We are using it so many times while we are coding for general purpose things, or for scientific reasons, or whatever the reason we are coding. Whenever a mathematical expression or condition, you are dealing with the condition, we will definitely go by this assignment operator. So assignment operator starts with equal to symbol, which is assigning a value to a variable. And we can assign a value only, or we can also put do a simple calculation and then assign a resultant also. You look at all the other examples, then except the equal to, you just plus equal to means there I'm actually x equal to x plus 3. So that will be shortly written as x plus equal to 3. So here we are doing two operations, we are performing two tasks. One is we are adding x with 3 and the resultant is will be stored in x itself. So we are performing two different tasks, but we are cut short and we write simply as x plus equal to 3. For all the operators, for all the arithmetic operators, you can perform the same. So that is the case, and we'll go with an example and brief it with the example. Here you can find the example. In this example we got one number x, we got 3 as a user input and is assigned to x. Then we try to assign x plus equal to 3, which is equivalent to x equal to x plus 3. So you know the result, 3 plus 3 becomes 6, so x equal to 6 there. And x minus equal to 3, which means x equal to x minus 3, then 6 minus 3 becomes the 3 again, so x equal to 3 in the next print statement. And x equal to x, so here you can see x star equal to 3, which means x asterisk 3, x equal to x into 3, so 3 into 3 becomes 9, so x equal to 9 in the next print statement. And finally x slash equal to 3, which means x equal to x over 3, x equal to x by 3, so 9 by 3 becomes 3.0 because this is a normal division, this is not a floor division, so it returns only the float value 3.0. So this is how you could map the operators and the assignment operators and the outputs. The next important point we have to discuss about is operator precedence. So whenever you are going to deal with more number of operations on a single statement or on a single expression, so you need to get a choice which is the first operation you need to perform on the numbers, right? So here to address the problem of which to go first, which to go next, the precedence, Python itself gives an operator precedence. So this is the way you should proceed. So parenthesis is the topmost priority. Whatever you put inside the parenthesis, that will be executed first, that should be computed first. So next follows is exponent, so to the power. So whatever we gave as a power to a number, that will be executed next, and which is then followed by division, multiplication, addition and subtraction. So this is how it will follow. And as you look out in the slide, it goes with parenthesis, exponent, division and multiplication, floor, division, modulus, and then finally addition and subtraction. And again there will be some question. So what if the equal prioritized operators will come next to each other? Which one do I perform for the first? Whether should I perform, for example, if multiplication and division coming together without any parenthesis, so which one should I go first? That will be discussed in the next slide. So whenever two or more operators have the same precedence that comes in the same expression, associativity helps to determine in which order you has to perform the operation. So associativity is the order in which an expression has to be evaluated whenever the multiple operators of the same precedence is occurring in the same expression. Okay, so we are following two precedents. One is left to right associativity and right to left associativity. Almost all the operators in Python follows the left to right associativity except one operator, which is called as exponent operator, that is to the power. So that only follows the right to left associativity, except that rest of the things follows left to right associativity. On the order coming from the left, you has to proceed. In case if you are having the same prioritized operators coming sit next to each other, so you has to go from left to right. So that is the key point here.